I may have cracked. Okay, voting in progress.
Yeah, hi everyone. My name is Joshi, and I'm a software engineer at Google. I'm working on the implementation of compression dictionary transport in Chrome. Patrick, left top is also from Google. He is joining remotely today. He's working on the specification of compression dictionary transport. Compression dictionary transport. This is a new attempt to use previous responses as a compression dictionaries for future requests. This feature is client-driven. That means the browsers have to decide whether to use dictionaries to avoid leaking information across privacy boundaries. Also, this feature is compression agnostic. The standard and broadly are currently supported, but new dictionary-aware compression schemas can be adapted in future. One example of this feature is using the previous version of a resource as a dictionary for a future version. For example, the YouTube JS player updates a few times a week, and all version can be used as a dictionary to compress another version of the file. Another example is a custom dictionary. You can build a custom dictionary for your HTML pages or JS files that has common templates in it. You can sideload a dictionary as a part of the navigation that can be used in future requests. This is a result of lab experiments. Using dictionaries, we can hugely reduce the transfer data size. The left side graph is the transfer data size of search result page HTML. Using a dictionary, the size can be reduced from 100 kilobytes to around 20 kilobytes. The right side graph is the transfer data size of YouTube player JS library. Using the previous version as a dictionary, the size can be reduced from 1.8 megabytes to less than 200 kilobytes. We introduce a new HTTP response header used as dictionary. This is a way of signaling that the resource is available as a dictionary for future requests. The value of this header is a structured field dictionary. Match is the most important one. This is a URL path pattern. Future requests matching this pattern can use the dictionary. For security reasons, this pattern matches only with same origin request that the dictionary was served from. There is an optional TTL, time to leave field, to indicate how long the dictionary is allowed to be used. This is independent of the cache lifetime. Currently, Chrome is using expires for this field. There is another optional hashes field to indicate hash algorithms supported by the server. The hashes are used by clients to advertise the available dictionary. Once the client has a dictionary and it thinks it can use the dictionary for a given request, the client advertises the dictionary in a stack available dictionary header. The value is a hash of the contents of the dictionary. We currently have two new content encodings, BRD for broadly with a dictionary, and ZStandard or ZStandard with a dictionary. As I mentioned before, this can be extended in future. If our new better delta compression schemas will be proposed, for example, Wasm binary aware compression. Clients can negotiate the compression schema using accept encoding request header. If the server has a matching dictionary and supports the content encoding, it can serve the content compressed using the dictionary. The content encoding response header must be the used compression scheme. And it is very important to add accept encoding and seek available dictionary in the value header to avoid cache collision. We also introduced a new dictionary link relation type. This can be used for both HTML link element and HTTP link header. When the browser detects a link rel dictionary, it will load the dictionary while it is idle. This is an example of a delta update use case. A user accesses a video site. The browser fetches player v1.js. The server returns a normal broadly compressed script, which is about 1 megabyte. The response header contains a new use as dictionary header that specifies a path with a wildcard. This player v1.js can be used for any future fetches for the matching URL in the same origin. 1 week later, the user comes back. The player has been updated. The browser fetches player v2.js. The browser will set available dictionary header with the hash of the dictionary because the hash is still in the browser's cache. And accept encoding HTTP request header will contain a new compression encoding, BRD, which indicates shared broadly support, broadly dictionary support. The server can return a delta compressed version of the player, which is much smaller than the broadly compressed version, like 100 kilobytes. The body response header should contain available dictionary to handle cache resources correctly, especially CDNs in the middle. This is another example of an external dictionary use case. The user accesses a shopping site. In response of this HTML file, there is a new link rel dictionary header, which is pointing to dict.dat. The browser downloads the dictionary dict.dat when it is idle. The HTTP response header contains user's dictionary matches equal item / header. So the browser will use the dictionary when accessing the shopping site in the future. The HTTP request for HTML files under items will contain available dictionary header. The server can return a shared broadly compressed version of the HTML file, which is much smaller than the broadly compressed version. Privacy. The privacy protections are all managed by client side. The clients have to decide whether to use dictionaries to avoid leaking information across privacy boundaries. For browser cases, at least all the dictionary are partitioned with the caches and cookies. They are assumed to be private information that belong to the session in the partition that the browser is currently navigating within. Also, they must be cleared whenever cache or cookies are cleared. Security, most importantly, dictionaries and compressed resources must be coarse readable. We are assuming that an Oracle attack can reveal the dictionary and the delta compressed data. So we only allow using the dictionary when you can read the contents of the response from the page. Implementation status in Chrome. We have started the origin trial with shared portrait support from Chrome 1.17, and shared this standard support will be available from Chrome 1.18. See this page for more details. It's some links, and that's all.
And say before we stop recording, I did have a couple more things just to add on a little color. Standards wise, most of the protocol wire level stuff is being discussed in the IETF HTTP working group. They adopted it and agreed to work it through, so hopefully we'll get an RFC sorted out there. The browser specific parts, the link rel equals dictionary and the CORS protections and things like that are going to be going through the W3C process into the HTML spec, hopefully. Still need to kick that off. There are, I'd say, some active areas of discussion. The match string in particular on the use of as dictionary response is one of the more active discussion points. There's some desire to reuse the URL pattern stuff that's being used for service workers, which provides a fair amount of flexibility in the match patterns. The HTTP working group side of things much prefers not having complex processing, although it's all of the processing is done on the client side. So hopefully we can get some adoption there or some agreement on what that match pattern complexity needs to look like. It does require stable file name patterns for the things that you want to use dictionaries for. So if you're going to be compressing JS resources and you have a main app.js, you need something that identifies the app.js as a stable path from one release to the next. Using just a raw hash of the contents will not let you use a dictionary, at least the way things are defined currently. And there's some discussion on the uses dictionary response right now to know what the dictionary is that's being set, to know if you already have it. It's all keyed by the hash of the contents, which unfortunately you have to process the entire response before you know the hash. And so we may be looking at some helpers where there could be an advisory hash included in the response as well that intermediaries and even the client could use. Still verify the hash if you're going to be storing it, but just for a quick cache lookup to see if I already have this one to prevent having to parse the entire response just to find out you already have it in cache. And there are size constraints on various parts of it. I believe we have a 100 megabyte per dictionary item limit currently in Chrome. The Brotli CLI won't compress anything against a dictionary bigger than 50 megabytes currently. Z standard doesn't have that limit, but there are, depending on which release of Chrome you're experimenting with, different limits that we're exploring, increasing and fixing issues and things like that. But it's all still fairly active. And there is an overall dictionary cache size limit as well that we're exploring, partitioned like the cache as well. I think those were all the active highlights.
Awesome. Thank you. I will stop.